2020 at a glance. Dear friends, all of you know, after 34 years, so we have a new education policy, National Education Policy 2020. At a glance, what are the changes take place in the school arena? Every child passing out of the school should be equipped with at least one skill by which he can lead his life after the school by doing that skill as occupation. No rigid separation in between arts, science, commerce, curricula and extracurricular. That means equal putting to all the subjects. There is the one student can take economics with physics, with music and art. So here we are giving lot of opportunity to develop their likeness towards the subject. Content to reflect upon critical thinking, inquiry based, discovery based, discussion based, and analysis based learning, along with art integration and experiential learning through case based study. Just now, Niranjan sir told about experiential learning. Thank you, sir. And 360-degree holistic progress card equipped with 21st century skill and capabilities. So 360-degree holistic progress means earlier we are only judging about academic part. Now we have to judge not only academic, other curricular areas also, vocational course also, and all three angles we have to study it, then we can provide a report card to these students. So our job is more serious now. So let us, how to handle this NEP 2020, we have to update ourselves. So now my topic is skillful learning of probability. So then let's see what is pedagogy and what is the NEP given to us.
जिसे जवाब मिलेगा वो हाथ ऊपर करेगा. देखते हैं कौन फर्स्ट आता है और कौन लास्ट. Your time starts now. टाइम अप सर, टाइम अप. क्या किसी को जवाब नहीं मिला? अब अपनी लाइफ का 1 मिनट रिवाइंड करो और सोचो. जब मैंने ये सवाल पूछा, किसी ने ये सोचा कि आज कुछ नया सीखने को मिलेगा, मजा आएगा? एनीवन? सर? नहीं, सब रेस में लग गए. ऐसे पढ़ के फर्स्ट आ भी गए तो क्या फायदा? आप लोगों की नॉलेज बढ़ेगी? नहीं, सिर्फ प्रेशर बढ़ेगा. और ये कॉलेज है, प्रेशर कुकर नहीं. अरे चाबुक के डर से तो सर्कस का शेर भी उछल के कुर्सी पर बैठना सीख जाता है. लेकिन ऐसे शेर को हम वेल ट्रेन्ड कहते हैं, वेल एजुकेटेड.
डियर फ्रेंड्स, किसी को हराना अहंकार है, खुद को बेहतर बनाना संस्कार है. We should teach our student what is the difference between well educated and well trained. The pedagogy, what do you mean by pedagogy? It is the science and art of the education and learning theory. As there are different fields of study in other subjects, this is the study of teaching. So, what are the innovative classroom practices? My friends, I may take a pause here. Almost all know that these are the learning procedure, the classroom practices often you are using in your classroom transactions. Active learning. During your teaching, you involve the students actively. Bloom's taxonomy, how to handle lots to heart while preparing the questions. Case study method of instruction. You will give a situation student has to analyze. Either you can do in the school or you can go to a tool, study tool. Then you will give the practical exposure to students. Flipped classroom, reverse the role of the teacher. That means it is a blended learning. Student has to study at home. Only he will come to school to clarify his or doubts. Gamifications. Through games, we can teach him the mathematics, any other subjects. Peer instruction. Give certain works they can do grouply, or you can make pair student pairs, they will do together. From their interactions, from their association, they can learn many things. Student engagement system. So system means you have to arrange some seminars or other quizzes where student engage or participate that program with confidence. These are the things. Is it head or tail? Could you guess? Yes. Nobody can guess here. That's why tossing the coin is age-old process to decide which team to bat and which team to play fast. Still, today also you are practicing. So this is a very fair coin toss. It's equally likely. Here I can take a pause. All of you know that there are three types of probability we are dealing with in the school curriculum. One is experimental probability at standard 9, then classical theory of probability in class 10, then axiomatic probability in class 11. So then proceeding further, let's unfold these terms. The terms are impossible, unlikely, given chance, likely, certain.
The number of ways an event can happen divided by the total number of outcomes gives a fraction. And that's what we mean by probability. One means total certainty, naught's impossibility, and the chance of anything happening lies in between. And that's what we mean by probability. Toss a coin and there's an even chance of getting heads, but there's also half a chance of getting tails instead. If the probability is greater than 50-50, then the likelihood of an outcome's looking good. And that's what we mean by probability. When you throw a single die, no matter what you pick, the chance of getting any number's only 1 in 6. And that's what we mean by probability. And that's what we mean by probability.
Let's friends, again, this is the case study on use of marks and its effect during COVID-19. Let's analyze the instances. Here I am giving some anecdote to you. The boy is affected by corona. Girl is not affected by corona. I did the study. What is the rate the corona spreading over and with use of masks? The case study, how much you can reduce the corona by using the masks. The first instance, all of you can see, the boy is coming contact to the girls, both are not using the masks. So then there is a fair chance she might have caught by corona. That chances is 90%. It's obvious, all of you seen that. Then you will go to second instant. Could you relate that first figure to one of the terms of the here written? That event whose probability is nearer to 1 is likely, or you cannot tell certain. Certain is at 1 point, that is 1. So then we'll go to second instant. Here, boy is not wearing the mask. Girls wearing a mask. And then there is a chance of spreading corona from boy to girl. What is the percentage? 70%. That means we understood in the second case, the who is the affected by corona, he must wear masks. Then we'll go to third case. Third case, now boy wearing a mask. Still then there is a possibility corona can spread to the girl as girls is not wearing the mask. That is the probability is 40%. Then could you term it which probability it is? Unlikely, which is less than 50%. Then go to fourth case. Very interesting case. Both are wearing the masks and boy is affected by corona. Still there is a chance. And also they maintain 6 feet distance. 6 feet distance between them. Still there is a chance. The C might have that is 1.5%. So there is a still chance. Here I can request every colleagues, every friends, every teachers, everybody who are present in this virtual platform, request sanitize yourself, maintain distancing, and obey all the rule and regulation of government. So now we'll go to next. This is reminiscing nostalgic moment of the childhood filled with probability. Everybody can relate his childhood to this picture. Is it not equally likely event? Yes, it is equally likely. So both have equal chance to occur. So I request everybody, now you can attend this poll question. In a non-leap year, the probability of having 53 Tuesday or 53 Wednesday is, your time start now. Let's friends, you can. Question is, because I am in the cross path, I am not getting what is this answer. I am pulling your opinion. Many of you are given opinion as 2/7. As 2/7. Many are given opinion as 2/7. Yes, friend, I must clear here. Its answer is 2/7. Congratulations, all of you. And thank you. You are giving right path to me. I am in the cross path. You guided me. That's why I need your pull here. Thank you, friends. Thank you. Now here is breaking assignment. Here is breaking assignment to you. So breaking assignment is a divisor of 2700 is selected. If the probability that it is a multiple of 4 but not of 5 is 1/5, then find the value of t. Yes, friends, give a try to these problems. Can you figure it out? Yes, I'm giving the time to you. And also, I'm providing some hints to you. Could you by hints you can do? Now here is the hints. The hints is before you. Hints is before you. Yes, I'm giving time to you. Okay, let me discuss. Discuss is 2000. Thank you, Gauraji sir. Dinesh Das sir. Okay, all of you. Now what are the total possible ways we can select the factors of total possible ways? total possible ways. Possible ways. So what are the total possible ways to find out the factors of 2700? Let's friends, we'll discuss. I've collected the prime factoration of 2700, that is 2 square, 3 cube and 5 square. Yes friends, and both the 2 I kept in a box. All the 3 3s I'm kept in a box and all 2s 5s I'm kept in the box. So then I can select from here no 2s, 2 2s or 1 2s. This can be done in 3 ways because I cannot select any of the 2s. I can select only 1 2s. I can select both 2s. Then this can be done in 3 ways. One more than whatever the number present here. Factors present here. Now, come to second box. I can select no 3. I can select 1 3. I can select 2 3. I can select 3 3s. So then I can get all the factors of it. It can be done in 4 ways. And then from here, how many ways I can take? 1 5 and no 5, 1 5 and 2 5. So this can be done in how many ways? 3 ways. Then what you understood from here? How many factors are there? 1 more than that. How many numbers are here? 1 more than this. How many numbers are here? 1 more than this. So then total altogether it is equal to 36. And now we'll find out favorable outcomes. Favorable outcomes. What is our favorable outcomes? Anybody? Now it is must be a multiple of 4, but not multiple of 5. Then these from this fast box, I have to select both tools. The both tools only can selected by one ways. And then we'll go to there is no restriction. There is no restriction on 3. This can be done in 4 ways. And 5 has a restriction. Then it is not selected. None of the 5 selected is 1. Then that is equal to 4. Your colleague, someone is asking me in the chat that what is if you one will select all zeros. What do you mean by that? Sir, it means that 1 is the trivial factor. You are not selecting 2. You are not selecting 3. You are not selecting 5 means that is 1. 1 is a trivial divisor of any number. That's case. Thank you, sir, putting such type of question in the chat. I feel honored. So now probability is P is equal to favorable by possible. That is equal to 36 and that is 1 by 9. In our question, don't confuse about this P. This P I use for probability. In the question, it is given as 1 by small p. In the question, that is given as 1 by small p. Now, what is the value of P? P is 9. Right answer. So, this is the problem. Now I'm going to perform a activity in front of you. I'm just decoding the geometrical probability. I'm going to decoding geometrical probability for here. For that matter, now I'll discuss in the directly in live. Once again, we'll discuss that activity before you. I know, my friends, this is the time how we are handling the corona. Also, we can manage this technology. With this knowledge, we can teach our students the 21st century skills, how they can tackle any situations will arise in their life. So the same activities I'm going to live, and let's the activity I'm telling what is the question before you. There are set of parallel lines D distance, t distance apart. A coin, I have taken a coin whose diameter is d. This is the coin. The diameter is d. The coin diameter is d, and set of parallel lines. It is t distance apart. So now you can see clearly here. Now randomly this is diameter d, and the parallel lines t distance apart. Now randomly I am throwing the coin. How can you find the probability? What would be the probability of coin will intersect? It lies in the yellow region. The center is lies in the yellow region. What is yellow region? Center is lies in the. It is d by 2 distance. Half of the diameter of the coin. It is the half of the diameter of the coin. Half of the diameter of the coin. If coin will fall in the yellow region, then it will intersect one of the line. If it is not fall on the yellow region, that means center of the coin must be lying on the yellow region. What is the distance of yellow region? It is d by 2. Similarly, in the other side also, I have taken a pair of parallel lines, and the total possible is the dt parallel lines, that is the distance apart between two parallel lines, and the d by 2 is the half of the diameter of the coin, that is radius, and here radius. If the center of the coin will fall on the yellow region, it will intersect one of the line. It will intersect one of the line. If it does not fall, it will not intersect. You can see here. You can see here. If it will not fall, it will not intersect. Then my question is, what is the probability if coin will randomly fall, coin will intersect one of the parallel lines? Yes, friends. Now we'll look at it is a geometrical probability. What is geometrical probability is we have to look at the coin may fall horizontally anywhere. It does not affect the things. Only it is affects if it's vertically. What is that? Now the distance of t is between two parallel lines, and that is total possible outcomes. Now the region, if the center of the coin will fall in the yellow region, that is d by 2, it's radius of the coin, then it is intersecting one of the line. Then the favorable is this side, either side of the parallel lines, that is one pair of parallel lines have taken, one side is d by 2, another side is d by 2. Then total possible is to t, and favorable is d by 2 and d by 2. Then all of you know that the probability is favorable divided by possible. So favorable is d by 2 plus d by 2, and possible is t, and it is equal to d by t. My friends, again I can tell, if any student asks you, sir, why you are selecting this way? We have known that it is a ratio between two numbers, then you can draw the slices here, making very thin slices here. You can break the several parallel line you draw between this one pair of parallel line. Then how many thin lines you can count? That is called total number of possible outcomes. And how many fall within the yellow region? That is favorable region for the probability. Then favorable by possible is equal to total probability. That we can get probability is that. So favorable by possible is d by t. So it gives an idea how student can do. What I'm telling, that is called point count techniques. That is called point count techniques. Dear friends, you can see here, if the coin center fall in this region, that is favorable region. We are slicing it small. region, then how many regions can fall here? So here how many? That's why directly I'm taking this distance matter for favorable outcomes. The whole distance matter for possible outcomes. Then its probability is d by t. Thank you, friends. And this is the coin problems probability, which motivates me to do the another activity. So here the activity for you. So before going to activity, let me introduce one. Yes. I don't remember.
池塘边的榕树上，知了在声声叫着夏天。操场边的秋千上，只有那蝴蝶停在上。
Okay, friends. Now we'll pause this and think. Is it not a geometrical probability? We are struggling to passing the thread through the hole of the needle. Could you think about this? Is it if you think the hole of the needle is a dartboard and thread is a dart, the dart will hit. That means what should be the probability? The same thing I discussed in the previous activity. The hole of the needle is the dartboard you measure. Then whatever the area of it, it can be go up for the possible outcomes. Then the 1 point is favorable. So then what is the probability? That 1 by the area of this whole region. So needle, then we can discuss virtually these problems. And the virtually problems is Buffon's needle problems. Before starting this problems, let me brief about the Buffons. Buffon is a great mathematician. And it's late 17th century. He has estimated the value of pi by this method. And that's, I'm going to make you understand. Our students are doing this activity. This is a statistical probability, estimating the probability by doing activities. So what Buffons did here, now I'll discuss virtually. Then how to find pi, I'll discuss physically in my activity. Let's friends, what is the Buffons activity? Now suppose if you take the needle randomly, the needle is randomly thrown in the set of parallel lines. It is a set of parallel line grids. Then you are throwing the needles in any manner. If I have constraint that all the needles will fall in a particular manner, that means perpendicular to wherever it will fall, it will must be perpendicular to lines. Yes, friend. Wherever I'll make constraints, and that the randomly falling needles is always perpendicular to it. Then what will the probability of it? So here also the probability is, I'm just okay now. Okay, clear this so that so any needle will fall. It is perpendicular to it. Here also perpendicular. Here also perpendicular. If I constant, then any of my friends can tell me what is the probability. It is just previous activity. The length of the needle, and I'm constraint here. The constraint here, needle length is d, and the space between two parallel lines is t. Space between two parallel lines is t, and needle length is d. All of you. Now, and condition is that d is always less than t. Then, if I make constant, then what should be the probability? I think it is quite similar the previous activities. The length of the needle is the favorable outcomes. Length of needle is favorable outcomes. That is equal to D, and the vertical distance here is equal to possible, then D by T. Yes, friends, correct. But it is not in my hand. All needle I cannot make constant that whenever will fall, it should fall in a particular way. That means perpendicular to any of the line. Then suppose the needle is fall any orientation. Needles are falling random orientation, variable orientations. So random orientation or various orientations. So it may falls one of the needle in this orientation, it's fall on the one set of pair of line I'm discussing. One pair of parallel lines I'm discussing. If needle is constrained that it will fall in this way, then all needle wherever fall, the parallel to it, that is I'm talking now, that case I'm talking now, all the needle is always wherever fall in a particular orientation. That means I'll draw a line parallel to horizontal, means imaginary line, and it makes a certain angle, needle makes with it, theta. Then, my friends, what would be the projection from the endpoints of needle to this line is equal to, already you know, needle length is D. Needle length is D, and it is D sine theta. It is definitely D sine theta. Then if I'll make all the needle in the same orientation, wherever it will falls, it will make theta. Wherever it will falls, if it will make theta, then I can make constant. Then what should be the probability, all of you, all my friends? This is case 1. This is case 2. If I make a constraint that whenever needle will fall, it will fall in this way, then the probability is d sine theta by t. Now, both the things is not in our hands. Both the things is not in our hand. The randomly falling needles is falling over the set of parallel lines in variable orientations. Both the things is not in our hand. Then I'm discussing the anyway the case 2. So all of you understood this. Then I'm going to second case, third case of it. Let me clear this chart, then let me clear my drawing and doing. So that is equal to, now case is that less needle will fall any orientation. Any orientation. Let assume that it falls in any orientation, any needle. I'm doing one figure, let it is theta. Then I've drawn a projection here, perpendicular. It is already, you know, this is length of the needle. It is d sine theta. This is d sine theta. Now, the here two variable are here. Theta can take any values because it is variable orientation are there. So what is the value of theta? So value of theta means if you rotate it, you will go to up to pi by 2. Then after it, the same identical rotation will occur. After it, same identical rotation will occur. Then the orientation can be varies. All the orientation can be varies that it is from pi by 2 to 0. It's can fit. One of my friend is asking in the chat, sir, why you are making constant d is less than t? Sir, d is less than t. I'm taking the point. The needle will not intersect at a time two parallel lines. That's my answer. If you'll make it the equal or more than that, it can intersect at a time two lines, and more bigger than it can more lines. So then that is the constants. Thank you, sir, posing this type of question, encouraging me. Thank you for. And then now all of you see, if theta is lies from 0 to pi by 2, then now I'm telling what is the probability at that time, because it's variable orientation. The probability is, now I can take this is the projected, this is called projected length of, I'm taking that projected length, variable projected length. What does it mean? So I'll do any orientation, yes, another orientation. I can take its projected. This is another projection. This is another projection, and all the projection are added and average over it, then divided by total possibilities here, this space T. The total is T. You already understood that the total is T, the gap, the spacing between two lines, that is T. We have no doubt about it. Then how to get this average projection? All my friends understood what is average projection? Average projection means any orientation manner, anywhere needle will fall, I'll take its projection, and such type of projection I'll add an average over it intervals. Average over a number of orientations. Average it over number of orientations. That is DP. This is the probability. Now, how to find average? Let me do that. So average is nothing but it is equal to, so average dp is equal to 0 to pi by 2. It is pi by 2 integration, because all the orientation can happen 0 to pi by 2, and d sine theta with over small orientation d theta, integrated over small orientation d theta. As it is average, then average is upper limit minus lower limit, that is equal to pi by 2 minus 0. That is average. Under the which interval you are doing, final number minus initial number, all sum of you are doing, that is the average over it. Then if you do that, if you do calculation of it, all of my friends, you can find, all of you know that the sine theta integration and this pi by 2 will go up, it is 2 by pi, okay, and here d is a constant, will come out. Then integration of sine theta is equal to minus cos theta over 0 to pi by 2, over 0 to pi by 2. Then from it, pi by 2, you know that 0, and 0 is 1, minus of minus is plus 1. Then we got the value is 2d by pi, all of my friends. Then what is the probability? The probability, if I put this value, this is your dp value is this one, dp value is this one. I can use any other color to show you. So this is dp value, this is dp value, this is dp. Now dp value I put, and in probability I substitute this value. Then 2d by pi t is the probability. Yes, 2d by pi t. Now what is my experiment? Now I'll tell you. If I keep, for instance, what is the length of d, and it's twice is the space between two lines. Let's say if t is always twice of d, then what solution will get? What solution will get? The probability became what? So t is equal to twice of d, you will put here, then it will reduce to, same probability is reduced to 1 by pi. Same probability will reduce to 1 by pi. If the t, the spacing between two parallel lines is twice of length of the needle, so twice of length of the needle, then a peculiar things we are finding here. This one our student is doing experiment in school exhibitions. Sir, we can find the estimated value of pi. This is gives the birth of the statistical things. This is probability. How can I do that? Now I'll show in the activity. In the real activity I can do. Then pi is from here I can get. It is equal to 1 by p. 1 by p is, if you write, this is equal to the number of sample space divided by number of favorable. Let's see that experiment. Okay, friends. Okay, friends. Now we'll do this. All of you. I'm taking the needles here. This is set of parallel lines. I'll put the needles on it. What I discussed there, you can see here. First point I discussed that if all the needles are constant to fall in the perpendicular way, then its probability is d by t. D by t. D is the length of the needle, and t is the over t. T is the total possible outcomes, and L is the favorable outcomes. If all the needles will constant about one orientation, you can see here, then what is the probability of it? Is d sine theta divided by t. Then I discuss how to find the probability of this and how to find pi. Today, I'm doing in your front one experiment. Already there are 3 needles. Now I'll randomly throw this total 47 needles I'm putting here, 47 needles. Then randomly I put, all of you see, randomly I can put. I have did this experiment in 3 times I did, and I found it is coming out of 50. One time I get 16 are intersecting the line. Second instant I got 17 needles intersect the line, and third instant I got 15 are intersecting line. Now all of you take the calculator and calculate its estimate value of pi. So 50 by 15, one instant, because I've already told the approximation value of pi you can do by this needle activity, or instead of needle you can take matchsticks also, or take 100 more number of matchstick will take, more number of needle will take, then you will get the very closer value of pi. So what will that? The total number of needle thrown divided by how many are intersecting the parallel lines, one of the parallel lines, both ratio is called as value of pi. So reciprocal it, and it's a Buffon's. This is a great work of Buffon's, and this is how we are utilizing in the school exhibitions. Students are doing this is pi, but they don't know the theory of where it comes and how they are doing these activities. Let's friends, we'll see this activity. Anybody having any, and it's very easy. Take a chart paper. What I did, I've taken a chart paper and draw the parallel lines with the space. You can take, this is what is the length, the gap between the parallel lines as twice of that. Easily your student can do, and you can once again see how it looks. That's thank you being connected with me doing this live activity. Thank you everyone. Thank you everyone. Now, okay friends, after doing these 2 activity, definitely we are interested to learn something more and fun. And by learning together and doing the some fun over it, it requires some leisure time to pause at some things and start understanding the conditional probability. My friends, everything is conditioned in this life. Nothing happens freely. You can know every day you are getting some news about the weather, where they are getting this weather report, and sometimes we are getting 100% is correct also. Now, what is that weather forecasting? Before planning for an outing or a picnic, we always check the weather forecast. Suppose it says that there is a 60% chance that rain may occur. Do you ever wonder from where this 60% come from? Meteorologists use a specific tool and technique to predict the weather forecast. They look at all the other historical database of the days which have similar characteristics of the temperature, humidity, and pressure. It is, and determine the 60 out of 100 similar days in the past it had rained. Yes, friend, in this juncture, I am excited to ask one of the small question to you, being a Indian. Uh, can you friends predict what would be happens? What will be happens if India is going to meet Pakistan in next World Cup match in cricket? Of course, some of my friends are writing it is 50-50 in the chat box. I can see. So 50-50. Yes, if you take the consideration on that day, it may be 50-50. But if you consider the whole past record of the India against Pakistan, in especially in World Cup, you will feel proud. India won all the matches, and till Pakistan is struggling to get a win a match in especially in the World Cup. Yes, friends. Then if you consider the past record, Now here I am making you understand what is the constant probability. Our happening should be one of the event of the past. It must be element of the past that can become as a favorable. Then if my element here, all the matches played between India and Pakistan, all are India won, then if next match will won means I have to search that event must be present in the whole in this past. So then it is equal to 100% because that same thing will come as my favorable. That is the conditional. The conditional means we will not go to the universal sample space. It should be conditioned. It will be restricted over one event. One event will occur and another event is going to occur. Respect to that event is called conditional probability. My friends, all of you know about it. Just I'm giving you an instant how to introduce that before students, taking the help of gaming. I told in during my presentation beginning what strategy I'm taking. Through game you can motivate. That's why knowingly I'm using cricket so that student will motivate. So now here is a life activity before you that I can do in your front. The question is that Raj has one pair of coin. Raj has one pair of coin and one pair of coin. One is head and one is tail. Now I can show you here. This is, you can all of you see, and this box containing one head, one double-headed coin, and one is fair coin. This is a fair coin, head and tail. Now question is here is that I have to draw randomly one of the coin and tossed it. I'll toss it in the front, tossed it, and I found it is head. I tossed it, I found head. I tossed it, found it head. Then can you predict it is a fair coin? Yes, friends, that is my questions. So if I got any one of the coin is selected, I'm getting head. That is the question. What is condition here? The condition is that, I'm getting a head. Head is happened already. It has happened. Then what is the probability to get? It is must be a fair coin. Through the tree, I can explain you. So all of you now live with me in the activity. So now activity before you. Okay, now move to activity here. So all of you friends, that questions I'm doing here in the chat. This bags contains 2 coins here. So either I can select head, one double-headed coin, or the fair coins. So out of it, one is selected. It can be fair, it can be double-headed. Fair here and double-headed. Now the fair coin can gives me head and tail. Fair coins can give me head and tail. So two branches of tree is grown. Now the double-headed coin, if I tossed, and it will give me branches will give me head and head. My question is the probability of fair when head is already happened. The probability of getting a fair coin provided the head has happened. So then this branch of the tree is trimmed up. This branch of the tree is trimmed up because already I know that only head is happened. Only head is happened means I trim the branches of the tree here. Then what is my possible outcomes? There are 3 coins showing heads, that is my sample space. And how many heads comes from fair coin? The only one head is come from fair coin. Then probability of it getting a fair coin provided the head is happened is 1 head divided by 3 heads. Then dear friends, can you do if 2 heads is occurred, it was occurred from a fair coin, that means once again we'll toss the coin and you will get double head, then it must be a fair coin. Now look at that same activities, you can grow same way. Now I'm growing that tree here, all of you look at here. Then this head it is a fair coin, it is again will give you head and tail. And this head, this is double-headed coin. Again, I'll grow, it will get 2x. And this coin is a double-headed coin. Again, it has 2 branches. As already it is conditioned that no tail will occur, I trimmed off this branch. So if I cut, then how many possible outcomes are there? There are 5 heads. Out of it, how many heads are come from the pair coin? Only 1 edge. Then 1 edge by 5 is equal to 1 by 5 is the probability. So all of you can see here, by tree method, I can solve each and every conditional probability. Stay tuned to explore more about any type of probability we can do by using tree methods. That is decoding of the probability through by growing trees. You can answer all type of probability. Friends, stay connected to see next to be explored in the next moment. Dear friends, I'm now is going to demonstrate another things before you. So this is a beautiful case study based question. All the friends, all of you look at here, a COVID-19 test was administered on some persons, and corona was detected through blood test. The following table shows the corona test result. Corona test result. Find the table. You have recorded all the data are collected. So first question, all of you, all of you. Now I'm going to write. Look at it. So first instance we are going to find the probability. It is A. Not affected by corona is A. Not affected by corona is A. May I draw the attention of all my participants, all the friends, those are linked with me, connected with me. Now look at a beautiful the relations here we can derive. So stay tuned to explore that. So here total test result is B, and let me assume a total test is B. Now can I write second question is nothing but B by A? It is nothing but B by A. So I'm just decoding the same conditional question. That means it is simply we are going to find probability of happening of A when B has happened. And this language is the probability of happening of B when A has happened. Very easy. Now one is inverse of another. Now could you figure it out? Could you figure it out? What is the answer? Now see, not affected corona, and positive result is we are going to find positive result became sample space. Our actual sample space is 93. We are not going to actual sample space. It is reduced to the new sample space 75. Look at it. So because already it is declared that test result is positive. Could you relate one of the scenario of day-to-day life? What kind of this? During this, due to 5 days back, you might have seen 5 days, 10 days back, might have come across the news. This MLA, this political leader is found positive, and also below that, to getting political mileages, some are declare himself as positive, and actually he is not a positive. That is the case. And another instance also in our colony, some are affected by positive, but they are declaring I am not affected. This both the scenario you might have observed during this pandemic situation. When some are affected, he is not declaring and as a positive, and then you can find here what is the probability. Probability is 5 by 19, and it is equal to 5 by 75. Then it is here directly, here the column, the sample space is 75, out of it is 5. And then here, now see, sample space here is, for second question, sample space is 19, out of it 5 are here. So both have written. Could you find, this question is very beautiful question. So A by B, using A by B, I can find This can be written as B by A and into a probability of A by probability of B. Okay, friends. Now you can write it's this value is known to you and this value, see that whether it is satisfying or not in this process. I'm getting it is 5 by 15, 75. I'm writing its value. And now I already got this is 5 by 19. You could find what is the value of A. Anybody? A means not affected. Not affected. What is the value? Not affected. Anyone? And not affected B. B is its test is positive. So test is positive. Its test is positive. 93 is the original sample space. You can get it quickly, all of you. So this result you can verify. This is a beautiful question. Both the side you can verify it is comes. See that 5 by 75 here. Here it is 5 by 19. All of you know that my original sample space is 93. Here my original sample space is 93. Only you have to find what should we put. Definitely 19. See that. So 19 is sample space. Easily you can get. And this, then this 93. Then what will comes? Sir, it is comes 90. And what will comes here? Look at it. 93. Probability of B. B is what? Test is positive. Test is positive. How many of you can find? It's 75. It's 75. Yes, you can get. Yes, sir, its answer is both the side correct. It is nothing but inverse the Bayes theorem or inverse probability. Can all the problem I can find A, a probability of A given B, and from that I can get probability of B given A. No, it's not possible. If possible, Bayes would have not invented the Bayes theorem. Thank you, friends. You can verify here easily, and this is a questions. Let me. Okay, all of my friends know that this time the board has changed the exam pattern, and in the latest sample question paper by CBSE, released by CBSE, we have seen two case-based study method questions. One is from 2 marks and another from 4 marks. And I have selected 4 marker questions for you as the poll questions. And the another changes we have seen that the board has reduced the markers, 1 marker, and now pattern of the question is 1 marker questions, 2 marker questions, 3 marker questions, 4 marker questions, and 5 marker questions. And total is 80. There is the total other things is not, but here board is asking 2 case-based questions, case study methods-based questions. Now let's explore. I'll request everyone to do this question in poll. In an office, there office 3 employees, Binoy, Sonia, equal, process incoming copies of a certain form. Binoy process 50% of the form. Sonia process 20% and equal is the remaining 30% of the forms. Binoy has an error rate of 0.06. Sonia has an error rate of 0.04 and equal has an error rate of 0.03. Find the conditional probability that an error is committed in the processing given that Sonia processed the form. Your chart is start now. Okay. This is the yes answer is 0.04. Yes, friends. Many of you are given right answer. You are given me. I am in the crosspath, and I request all of you will do another 3 bits while doing these problems. And this type of questions we have to frame from our friends. Thank you, friends. Almost all the answer is given. Many are this 90%, 92% friends are given. The answer is 0.04. Yes, friends. Congratulations. That is the right answer. That is the right answer. All my friends. Now here is the assignment. Let's take a pause. Decode all the problems of multiplication rules, independent events through the pictures and through colors. Let's enjoy. It's the method, tree methods. Now I'll enjoy with art integrations. Here is the question. There are 6 red, 4 green, 5 blue, and 5 yellow marbles in a jar. What is the probability of picking a green marble when, when a blue marble, if you do not put back the first marble? Could you answer this question, dear friends? Can you give a try to this? Let's decode this question through the pictorial solution. Means by help of picture I can decode it. I'm using the multiplication rule. All of you know that simultaneously occurrence of both A and B is equal to probability of A happening of only A into happening of B provided A has happened. Happening of B provided A has happened. So let's decode these problems. This is, if you see the formula, the work has done in 2 ways. Work is drawn as 2 ways. So first instance, the work is, so here first instance, the work, see that in the first case, there are four green balls, 6 red balls, and 5 blue balls, and five yellow balls. One green marble has to take it. Now one green marble here are taken out. What should be the probability? There are 4 favorable, and out of 20 marble it is 1 by 5. Then we'll go to second instant. Then I'm going to second instant. After drawing the green marble, there are how many balls are left? So 19 marbles are left. The 19 marbles, out of it 5 are blue, out of it 5 are blue. So then 5 by 19. Then the total probability here, getting the probability green and blue marbles, getting the probability of green and blue marble together, then by the formula, first happening of a PA is equal to 1 by 5. Happening of B restricted A is equal to 5 by 19. Just you multiply, you will get 1 by 19. That's why its name is multiplication rule, because one work we did, and one work we did, 1 by 9. Yes, many are given right answer. Congratulations, participants. All of you given right answer. Yes, there is a thumbs up from my side to all of you. So now we'll go to next assignment. Dear friends, we'll go to next assignment. So here is the question before you. I've selected some of the cards because we are always fond about the cards problem. So 2 cards are drawn successfully without replacement from a pack of 52 well shuffled cards. What is the probability that first card is a spade and second card is a heart? Dear friends, I'm not talking about my hearts. I'm talking about hearts of the playing cards. Okay. Now see the pictorial solution. Here is the pictorial solutions. Out of 52 cards, first I selected a spade. It can be done. What is the probability? There are 13 spade cards out of 52. This is 13 by 52, and it is end up with 1 by 4 by simplification. Then after drawing this spade, there are 51 playing cards remaining. From there, I'm going to take a heart. The probability is there is 13 cards of heart is intact, and it will be done. One card will be done from 51. So then the probability of getting this card is, yes, many friends are given right answer, 13 by 0 for 240. Yes, friends, it is 13 upon 204. Correct multiplications. Yes, friend, you encourage me, I participate. So thank you, friend. Next, decode this question. All of you, decode this question. A teacher has a box of crayons, and because students are very much like about crayons, that's why I've selected this question to know the beauty of the questions and connected to art. The teacher has a box of crayons that contains 6 red, 6 blue, and 6 green, and 6 purple. Knowingly, I selected the colors and to show the balls. So crayons. Disha picks a crayon out of the box. Then, without putting that crayon back, she picks second crayon. What is the probability that the first is a First crayon is a purple and second crayon is also purple. Yes, my friends, please tell me the answer. Yes, many are given the right answer. Many are given the right answer. So then pictorial form, yes, it is equal to 5 by 92. Yes, friends, correct. Congratulations, many of you are given right answer. Stay connected, stay connected, stay connected. So purple is 6 by 24, that is 1 by 4. And your second purple is equal to 5 by 23, 1 5. Then together it is 5 by 92 multiply. Congratulations, all of you. Many have given right answer. Yes, friends. Now see the mystery of.
Nope, heads. Sorry, heads again. Oh no, sorry. The answer was tails. Tails. Dear Tim and Moby, if there's a 50% chance of rain on Saturday and a 25% chance of rain on Sunday, does that mean there's a 75% chance that it will rain all weekend? From Jocelyn. No. This question involves probability, how likely some event is going to happen. In this case, you have two single events, the weather on Saturday and the weather on Sunday. Okay, on Saturday, there's a 50% chance of rain. 50% is equal to 1/2, so there's a 1 in 2 probability that it'll rain that day. And for Sunday, the forecast is predicting a 25% chance of rain. 25% is the same as saying 1/4, so that's a 1 in 4 chance of rain on Sunday. The probability of it raining on Saturday has no effect on the probability of it raining on Sunday. They're independent events. To find the probability of both independent events happening, we multiply the probability of the first event by the probability of the second event. So, the probability of rain on Saturday, 1/2, times the probability of rain on Sunday, 1/4, is equal to 1/8, or 12.5%. There's a 12.5% chance that it will rain on both Saturday and Sunday. Well, dependent events happen when the outcome of one event has an effect on the outcome of another. Say we've got 3 paper bags. 2 of the bags each contain an apple, and 1 contains a dirty golf ball. The probability of me ending up with an apple is 2/3. That's 2 apples out of 3 bags. What do you know? I got an apple. We know that one of those remaining bags has a dirty golf ball in it, and the other has an apple in it. The probability that Moby gets an apple is 1/2. 1 apple, 2 bags. Did you get the apple? Anyway, choosing those bags are dependent events. My choice affected the probability of Moby getting an apple. How likely was it that we'd both choose apples? Well, to calculate that, we take the probability of me choosing an apple, 2/3, and multiply it by the probability of Moby choosing an apple, or 1/2.
2/3 times 1/2 equals 2/6, which simplifies to 1/3.
So there was a 33.3% chance that Moby and I would both get apples. That makes sense when you think about it, because 1/2, or 50%, of 2/3 is equal to 1/3, or 33.3%. I don't want to trade, just take the other bag. No, this is my apple. I'm not trying to trick you. Take the bag, you've got a 100% chance of getting an apple. Get away!
Moby, I'll give you an apple from my side. Okay, friends, pictorial solution on the independent events. Now all of you know that while we are discussing on over the video, you know that one event does not affect another is called independent. One is affect, another is called dependent. So this is the question before you. The probability that A hits a target is 1/3, and the probability that B hits it is 2/5. What is the probability that the target will be hit if both A and B shoot at it? I did by the tree diagrams. So A has 2 options. It will strike the target or not, does not strike the target. Then each target, each A, there are 2 equally likely of B. When A not strike the target, B can happen not striking the target, and also B can hit the target. Then first branches of the tree I completed. Then there is another option when A strikes the target, then B may strike or may not strike. This can be happen on the two ways. Now, can you tell me which branch, which side is not happened? I put a red cross. Red cross means this question and other, if you add, multiply all, I can get, but if you do in the opposite way, negative way, then which one is not happens? Both are at a time not strike the target. Means A will not hit the target, B will not hit the target. And both A dash, B dash is independent. As you know, friends, if A and B are independent, then their complements are also independent. Then this problem I can do by that 1 minus their intersection probability. As is independent case, their intersection become multiplications. Then 1, the complement of A, already A is known as 1 by 3, its complement is 2 by 3, and B is known as, it is 2 by 5, its complement is 3 by 5. Then 1 minus 2 by 3 into 3 by 5 equal to 3 by 5. Yes, friends, independent events, its formula is probability of simultaneously occurrence of A and B is equal to probability of A into probability of B. Let's enjoy with another problems here before you. Now here the great mathematician comes, whose name is Best theorem. I have motivated in my previous corona problems, and that is called inverse conditional probability, is done by none other than Best. In this 18th century, Thomas Best pondered the question, does God really exist? Being interested in mathematics, he attempted to develop a formula to arrive at that, at the probability that God does exist from the evidence that was available to him on the earth. Many have same question, does God does exist? Still then we are not getting an answer. Dear friends, now we can get answer due to our belief and evidence. Later, Laplace refined Bayes' works and gave it Bayes' theorem. And here, all of you know that priori probability, likelihood, and posteriori probability and evidence. Already these things I discussed in my previous problems, corona problems. This is already now.
And B. Bag A contains 2 green and 3 red balls, and bag B contains 4 green and 5 red balls. Rohan drawn at random 1 ball from one of the bags. We can easily find probability of selecting any of the bag. Also, we can easily find the probability of drawing a ball of particular color if we know the bag. But can we find the probability that red ball is drawn from a particular bag, say bag A? In this case, we have to find reverse probability of bag A to be selected when a color of ball is known.
Here is the friend, the answer in your front in the by tree solving methods. I decode that the whatever video problem suggests probability of drawing a red ball from a bag A, that is the questions. And then out of 2 bags, I have selected 2 same color for 1 branch. That's why easily student can understand. And bag A contains 2 green ball and 3 red ball. Bag B contains 4 green ball and 5 red balls. Then out of 2 bags, 1 bag can be selected. Its probability is 1 by T. Then what is the A? A is an event selecting bag A. B is an event selecting bag B. Student can easily, and this type of question is very lengthy. You can decode by the pictorial form or arrow diagram. You can easily get its answer. That's why I'm trying to do that with integration, art integration, through art integration. So then first, then out of 2 bag, 1 bag is selected. Probability is 1 by 2. Selecting B is 1 by 2. Then after selecting bag A, from there you are selecting a red ball. So bag A contains 3 red, out of it 1 is selected, and total number of ball is 5. That can be done by 3 by 5. I've written in the down. You can see here the probability of this. Now if you'll go to then you will go to next one. So if selecting second bag and also drawn, then it is equal to this bag is drawn and red color ball, that is out of 5 balls, one red ball is drawn out of 9, that is 5 by 9. So easily you can decode this problems through that. Now here is the
John Bayes solved the problem of finding reverse probability by using conditional probability. The formula developed by him is known as Bayes' theorem. Before stating Bayes' theorem, let us first understand partition of sample space. The total sample space S can be partitioned or subdivided into set of events E1, E2, E3 and so on. Events E1, E2 and so on up to En represents a partition of sample space S. If no two events have anything common, that is, the intersection of any two events is a null set. EI intersection EJ is a null set phi. And union of all partition is the sample space S, and probability of the events should not be 0. In nutshell, we can say that the events E1, E2 and so on up to En represent a partition of the sample space S. If they are pairwise, disjoint, exhaustive and have non-zero probabilities. For example, any non-empty event E and its complement E dash together form a partition of sample space S. Since E intersection E dash is a null set and E union E dash will make complete sample space. This is one partitioning of sample space. There can be several partitions of the sample space. It means partition of a sample space is not unique.
Dear participants, here I'll set a poll for you. Those are, listen carefully this video. You can now, poll is before you. Okay friends, I got the answer. And pairwise, disjoint, exhaustive and have non-zero probability. Congratulations all my friends. Its answer is really answer. Some are given only pairwise and disjoint, but the answer is 84% are given the first answer. Congratulations all my friends, and thank you for your participation in this session. Thank you friends. Keep now
क्वालिटी की तरफ बढ़ते हैं। तो पर्सन है और वो क्या करता है, कहीं से उसको खबर मिलता है कि जो जंगल के अंदर जो केव्स हैं, केव्स A1 एंड केव्स A2, इनके अंदर डायमंड्स और गोल्ड बहुत सारे वहां पे रखे हुए हैं। तो वो क्या करता है, वो सोचता है कि नहीं, मैं जाके एक बार चेक करूंगा और आज का बड़ा सही दिन है मेरा, आज तो मैं बस अमीर बन जाऊंगा। वो क्या करता है, इसी थॉट से जाता है। सबसे पहले वो डिसाइड करता है कि वो कहां से लेके जाएगा। वो अकेले खुद जाता है, किसी और को साथ में नहीं लेके जाता है। तो सबसे पहले वो क्या करता है, केव 1 के अंदर वो जाता है और केव 1 के अंदर जाके वो देखता है कि यहाँ पे 2 गोल्ड के बॉक्सेस भरे हुए हैं और 3 डायमंड के बॉक्सेस भरे हुए हैं। तो अगर सबसे पहले वो दिमाग में सोचता है कि मैं कौन सा बॉक्स लेके जाऊं, क्योंकि मैं तो अकेला हूं, एक ही बॉक्स लेके जा सकता हूं। तो वो डिसाइड करता है मैं डायमंड का बॉक्स लेके जाऊंगा। तो अगर हम देखें तो डायमंड के एक बॉक्स को लेके जाने की प्रोबेबिलिटी क्या होगी, 3/5, क्योंकि आप यहाँ पे देख सकते हैं कि हमारे पास 3 जो बॉक्सेस है वो डायमंड के हैं आउट ऑफ ऑल 5 बॉक्सेस। अगर वो क्या करता है, उसके बाद एक बार वो घूमने जाता है कहाँ पे, केव A2 में। केव A2 में जाके वो क्या देखता है कि उसके पास टोटल 4 जो बॉक्सेस हैं वो डायमंड के हैं और जो 3 जो बॉक्सेस हैं वो गोल्ड के हैं। तो यहां से अगर वो डायमंड का बॉक्स लेके जाता है तो क्या प्रोबेबिलिटी होगी डायमंड के बॉक्स को उठा के लेके जाने की? बिल्कुल 4/7। ये तो काफी आसान है। तो वो सोचता है कि मेरे पास आज 2 केव्स हैं, डायमंड तो लेके यहां से जाना ही जाना है। तो व्हाट इज द प्रोबेबिलिटी ऑफ गेटिंग अ बॉक्स ऑफ डायमंड? काफी सिंपल सा क्वेश्चन है। तो इस क्वेश्चन का अप्रोच क्या होगा? जो जानते हैं अच्छी बात है, जो नहीं जानते हैं वो थोड़ा ध्यान से देखें। हमारे पास देखिए यहाँ पे 2 केव्स हैं, केव A1, केव A2। जो डायमंड का बॉक्स दोनों केव में है और उसको कोई एक बॉक्स लेके जाना है, तो इट इज वेरी एसेंशियल फॉर हिम कि वो पहले डिसाइड करे कि उसको केव 1 से जाना है या केव A2 से लेके जाना है। अगर वो सोचता है कि ठीक मैं केव A1 से लेके जाऊंगा, तो सिर्फ केव डिसाइड करने से वो बॉक्स नहीं ले पाएगा। वो पहले क्या करेगा? केव डिसाइड करेगा एंड यहाँ पे ये ध्यान से देखिए, बहुत ही इंपॉर्टेंट है। उसके बाद वो जो है गोल्ड हो या उसके बाद जो है उसके पास डायमंड है, ये वो डिसाइड करके लेके जाएगा, ये बात की बात है। लेकिन यहाँ पे जो एंड का यूज हुआ है, यहाँ पे हम करेंगे मल्टीप्लीकेशन, क्योंकि ये दोनों जो प्रोसेस है ना, उसको एक के बाद एक करके जाना है, सक्सेसिवली करना है। वो दोनों में से कोई एक नहीं कर सकता कि अगर करेगा तो उसको गोल्ड या डायमंड नहीं मिलेगा। तो यहाँ पे हम एंड का यूज करेंगे। अगर वो क्या डिसाइड करता है, नहीं मैं केव 1 में नहीं केव 2 में लेके जाऊंगा, तो वो और का यूज करेगा। इसका मतलब इधर केव 1 और केव 2, दोनों केव से वो नहीं लेके जा पाएगा। ये जो डिफरेंस है ना, ये काफी क्रिटिकल है, इसको आप समझिए। तो हम देखते हैं कि टोटल उसकी क्या प्रोबेबिलिटी होगी। अगर वो डिसाइड करता है कि वो केव A1 से लेके जाएगा, तो केव A1 को चूज करने की प्रोबेबिलिटी क्या होगी? दोनों दो केव है हमारे पास, तो केव 1 को चूज करने की प्रोबेबिलिटी होगी 1/2। और केव A1 से गोल्ड या डायमंड लेने की प्रोबेबिलिटी उसके आगे हम कैलकुलेट करेंगे। तो सबसे पहले हम यहाँ पे क्या देखेंगे? फर्स्ट चूज केव A1 एंड डायमंड फ्रॉम केव A1। आप समझ पा रहे हैं? यहाँ पे सब हम इसको जब मैथमेटिकली लिखेंगे तो हम क्या लिखेंगे? प्रोबेबिलिटी ऑफ चूजिंग A1 एंड प्रोबेबिलिटी ऑफ डायमंड गिवन दैट वी हैव चूजन A1। तो इसका जो न्यूमेरिकल वैल्यू होगा, प्रोबेबिलिटी ऑफ चूजिंग केव A1 1/2, और जो प्रोबेबिलिटी ऑफ डायमंड फ्रॉम A1 जो हम पहले देख चुके हैं, वो होगा 3/5। और जैसे कि हम यहाँ पे जानते हैं, एंड के लिए हम यहाँ पे क्या करेंगे? बिल्कुल मल्टीप्लीकेशन करेंगे। तो ये हो जाता है केव A1 के लिए केसेस। अगर वो केव A2 से लेके जाएगा, तो क्या करेगा? पहले वो केव A2 का चयन करेगा। और जैसा कि हम ये जानते हैं और ये मानते हैं कि केव A2 में हमारे पास 4 डायमंड के बॉक्सेस हैं, तो वो हम कैसे उसको कैलकुलेट कर सकते हैं? फर्स्ट चूजिंग केव A2 एंड देन डायमंड फ्रॉम केव A2। और चूजिंग ऑफ केव A2 का जो प्रोबेबिलिटी है, हम उसको कैसे लिखेंगे? प्रोबेबिलिटी P ऑफ A2 एंड प्रोबेबिलिटी ऑफ डायमंड फ्रॉम A2, जिसका न्यूमेरिकल वैल्यू हम जान सकते हैं 1/2 एंड 4/7, और एंड की वजह से हम यूज करेंगे मल्टीप्लीकेशन। बिल्कुल। लेकिन क्योंकि वो सिर्फ एक ही बॉक्स लेके जा सकता है, तो क्या आप ये समझने में कोई दिक्कत है कि हम इधर केव 1 चूज करेंगे और केव 2 चूज करेंगे? यानी वो दोनों कभी भी साइमल्टेनियसली नहीं होगा, कोई एक को ही हमें डिसाइड करना पड़ेगा। तो हम यहाँ पे और की वजह से ऐड करेंगे, यानी प्लस साइन का यूज करेंगे। तो ये जो वैल्यू है 1/2 इंटू 3/5, ये केव A1 से डायमंड का वैल्यू है, और जो हमारा 1/2 इंटू 4/7 है वो केव A2 से है, और की वजह से हम करेंगे
Yes, friends,
प्लस।
answer
बिल्कुल
is
सही।
41.
ये जो वैल्यू हमें यहाँ पे मिला, जो आप यहाँ पे बॉक्स में देख सकते हैं, ये है टोटल
Now you
प्रोबेबिलिटी।
can
लेकिन
decode this, the solving by tree diagram for visual learners. So same problems I decode through the tree diagrams, or you can see whatever we have listened through the video. I have decoded here. So selecting the cave 1 and cave 2, it is half and half. And from cave 1, selecting a diamond is probability is 3/5. And from cave 2, selecting diamond is 4/7. And the total probability PD selecting the diamond, either it's selected from the cave 1 or cave 2. Selecting the caves is half. and selecting the diamond 3 by 5 plus 1 by 2 into 4 by 7. It is 41 by 70, and that is 0.58. Congratulations, friends. Your answer is absolutely correct. Now, keep on motivating me. Let's see the another example. A doctor is visited to a patient from the past experience. It is known that the probability that he will come by train, bus, scooter, or car are respectively 3 upon 10, 1 upon 5, 1 upon 10, and 2 upon 5. The probability that he will be late are 1 upon 4, 1 upon 3, and 1 upon 12. If he comes by train, bus, and scooter respectively. But if he comes by car, he will be not he will not be late. When he arrives, he is late. What is the probability that he has come by train? Your message that Indian Railways are coming in late. Yes, these things you have to visualize. I'm decoding this question through a tree diagram. Let's see. I've used the train. It's the picture speaks a volume of things about the question. The coming by train is 3 by 10. Coming by bus 1 by 5. Coming by scooter 1 by 10. Coming by 2 by 5. And late in car 0. Being late in scooter 1 by 12. And being late in bus is 1 by 3. And being late in the train is 1 by 2. It's a base theorem probability. Then we have to tell that which one he wants to find. The he is late, you have to find he's come by train. The first branch divided by false color will multiply and add. So you can end up with the ratio 1 by 3. I don't know about it, just integrate the R to make this clearly. It is easy to teach every student this something. Now, could you guess this question? Could you guess this question? May I continue with the questions? Decoding of it. Hello. So now anecdotes, all the anecdotes. Okay. The anecdotes are here before you, and truth 3 by 4 and 1 by 4. Could you guess this question, friends? Could you guess? Yes. The decoding of the question. A man is known to speak the truth 3 out of 4 times. He throw a dice and report that it is a 6. Find the probability that it is actually 6. It is a very well-known, very familiar mindset. Now, there is a poll. All of you join in the poll. If 40% of the boys opt for the mathematics, 60% of the girls opt for mathematics, then what is the probability that mathematics student, if half of the class of population is girl? Yes, friends, the poll here. Yes, some are given answer. Yes, start answering. The answer is now. I'm saying the answer, everyone. Man speaks truth question. Yes, sir. Yes, sir. Very good. Your suggestion. Now you attend the poll question. My friends, just give me the answer of the poll question. Yes, many are given the answer. The answer is, now I can live you. Please. Yes. Now I can say it is true. Answer here. Yes. Many or majority of the participant given answer is 0.5. Yes, friends. So it's correct. And now, okay. Then you'll go to next slide. The assignment of the arm contains 4 balls. 2 balls are drawn and are found to be green. What is the probability that all balls are green? Here is the solution graph. You could find the decode it through the tree diagram. Yes, friends. Out of 3 situations I've created, this question was asked in 2015, and it is asked as a white bulb. I've changed into green bulb. And the container, first container containing 2 green and other 2 bulbs, and second container containing 3 greens and 1 other color, and third container is containing 4 green bulbs. Let's friends, I just selecting one of the containers 1 by 3, 1 by 3, 1 by 3. Then selecting first container, from there getting 2 green bulbs is C22 upon C42. That is end up with 1 by 6. And then second contender selecting 2 green ball is C32 upon C42, then half, then 1 by 3. Okay, okay. Now this is here is the using it. I don't know. I've just anywhere put my hands and got a blue balls. And this blue ball is drawn. And what is the probability of getting a blue ball? So I don't know what happens. I've drawn a ball and found to be a blue. Then find the probability of getting a blue ball. The ball is drawn and it is found to be blue and it is already blue ball, and find the probability. This is called total probability. Now question arises here. So blue ball is there here and here also. Blue ball is here and blue ball is here. And that ball where is it? I have got. Then I have to do a tree diagram here. This event. Then after selection, what I'll do? So after selection, then I'll find blue ball. Blue ball, and blue ball is taken as A, event A. And this is event 1 and it is event 2. And this is blue one. Then what happens? After this bigger one done, I'll find the probability of blue ball here. That is the question. That means this PAB1. And here notation is PAB2. Then both addition is total blue ball. So blue ball is getting a blue ball is A, and that can be PB1 into PAB1 plus PB2 into PAB2. This is the total probability. Then it is easy. Out of 2 beakers, 1 beaker is selected is equal to half. 1 beaker is selected half. 1 beaker is selected half. Okay. Out of 2 beaker, anyone you select, that is half, and this is half. Now next, after selecting beaker 1, what is the probability of getting a blue ball? A blue ball is equal to 5 out of how many ball? 8. 5 by 8. This is 5 by 8. And similarly, selecting beaker 2 is half, and after selecting beaker 2, what is the probability of blue ball? So blue ball is probability is 2 by 5. Then calculating here 1 by 80. The whole probability is this. Here is the assignment for your reference. A pack of playing cards was found to contains only 51 cards. If the first 13 cards which are examined are all red, what is the probability that missing card is a black? Here is the decoding of it. The picture itself is speaking everything about these problems. You can small annotates I used to get the problems rightly. So there are 2 colors here. Colors is important. There is a red and black. Selecting one is half. Then after that, a missing card is black. Then how many black cards are there? You could. This is the concept map. So far, I have touched all the concept: fundamental probability, geometrical probability, conditional probability, multiplication rule, independent events, total probability based theorem. Dear friends, let coexist with corona. Wear masks, follow the physical distancing, maintain hand hygiene.